Hello everybody, my name is Seth. I have chosen to do a tangent plane problem from our homework. This is going to be problem number 2. The directions for this pretty straightforward. It's going to be find the tangent plane of the function at the point that's given to you. Doesn't seem like an incredible amount of information given to you to do such a thing, but turns out it's pretty simple with just using the tangent plane formula. That formula reads as such: z minus function of x and y is equal to the partial derivative with respect to x of the point times x minus the x value of the point plus partial derivative with respect to y at the point multiplied times y minus the y value of the point. Not too bad. We only have to find a couple things. We have to find our value for the function, the partial derivative with respect to x, and y. The rest will do itself. The rest is pretty much given to us. So let's go ahead and start doing that. Let's find the derivative, let's find our function in terms of x and y. Let's restate that real quick. Square root of x minus y. Another way to write this, just equivalent. Some people might like to think of it this way: x minus y, the entire thing raised to the 1/2. I myself visualize this much easier than dealing with square roots. I like exponents, much easier for the chain rule, as we'll find out in a second here. Okay, let's plug our point in of 5, 1 from up here. Slide that in. We're going to get the square root of 5 minus 1, which is equal to, I'll just steal this one right now. It's pretty simple. I know I will use this part later on. It's equal to the square root of 4, which is equal to plus or minus 2. Here we have a conundrum. Why plus or minus 2? With the square root value, which one do we use? Well, if we go back and look at our point value for our function, 5, 1 is going to yield just a positive 2. So we'll stick with the positives for the remainder of this video here. We'll work with that. Okay, so we have that. That is one of our values for here, f of x. We'll box that in. That we'll need. Now let's find our partial with respect to x of the function in terms of x and y. Okay, now we'll use this part here. It seems a little easier. Let's use the chain rule. Bring the exponent down, keep the inside, subtract 1 from up top, multiply it times the derivative of the inside. Now we're only dealing with terms of x. So looking at this, we just have a 1 in front of the x, so times 1. Simplify this a little bit. We're going to get 1 over, because of the negative, 2 square root of x minus y. And that's it. Pretty straightforward. Let's find what our value is at the point. We'll get 1 over, 2 square root. Now we could just steal this from above. We'll write it out here. We'll just go through the dirty work and try this out. Just make sure we're not making any mistakes or check our work kind of from before. I kind of just rewrote the same thing, so let's try this again. 2 square root of 5 minus 1 equals 1 over 2 times the square root of 4, which is going to yield 1 over 4. This is our partial value with respect to x. Sliding this up a little bit, let's find y. F of y in terms of x and y. Going to turn out is going to be pretty much the same thing, only one difference. So let's break this down here. We're going to get 1/2 times the inside, subtract 1 from the exponent, multiply it times derivative of the inside. Now if we look at just y, we do have a negative sign or a minus sign in front of the y. So we have to take that into account. It's going to be multiplied times the whole thing times negative 1. We expand this out. We're going to get negative 1 over 2 square root of x minus y. Plugging in our point value here of 5, 1, we'll see that 1 over 2 times the square root. Now it's just kind of the same thing. Oh, I forgot my negative again, so you know what we'll do? We'll put it up here. 5 minus 1 is equal to negative, there we go, 2 times the square root of 4, which is going to equal, same thing, just negative. Get negative 1/4. Turns out that's all we need. We did all the dirty work. Now it's time to plug it into the formula and see what our result is. Let's slide this up here, get a new sheet. Okay, restating our formula from above here. There, let's slide that down here. Let's plug in our values at the same time so we can fit it all in this video here. Alright, we have z minus function at the point 5, 1 equal to the partial with respect to x of at 5, 1 times x minus the x value of 0.5 plus partial with respect to y of 5, 1 times y minus the y value 1. Okay, let's plug in what we found from above. Z minus 2 is equal to 1/4 times x minus 5 plus, now we have a negative 1/4 times y minus 1. Distributing out the quarters here, z minus 2 is equal to x over 4 minus 5/4 minus y over 4 plus 1. Oh, plus 1/4, excuse me. I knew something didn't seem right. That looks a little ugly, but we got the point. Okay, opening this up a little bit and simplifying. Z is going to be equal to x over 4 minus y over 4. Take our term, plus 1. That's where I got a little ahead of myself there. But that turns out to be our tangent plane formula. All right, we'll plug this into the applet and we'll see what we get.